So before we were solving equations where we had just one variable, or maybe the same variable multiple times, but all on the same side. Now we're dealing with equations where we have variables on both sides, and we're talking about how do we solve those. For the most part, it's the same, but there is a little bit of a difference. So when we solve these, we're going to use this acronym, Don't Call Me After Midnight. One, I'm not usually up after midnight anyway. But for this, the don't in this is for distribute. The call in this is for combine like terms. The me is for move a variable or constant. After is for add or subtract. And then the midnight is for, multiply or divide.
Is a move a variable?
Move a variable or constant. So distribute, combine like terms, move a variable or constant, add or subtract, multiply or divide. Don't call me after midnight.
No, so you don't want us to call you after midnight.
No, I don't. For some of the problems we go through, we won't need all of these steps. Sometimes we will. It just depends on what it looks like. Okay. You forget something? Yeah.
All that.
It's okay. It's okay. So for the distribute part, we're going to distribute on both sides at the same time. So this would give us 8x plus 4. We're going to bring down the negative 2x and the equals 8. This would become plus 4x plus 20. And then the call combine like terms, we're going to do that on the same side. So on this side we have 8x and negative 2x. On this side we have 8 and 20. So we're going to combine those on the same side first. Remember, when you're combining like terms, you're doing whatever it says. So 8x minus 2x and 8 plus 20. The me part, the move a variable or constant. When we have variables on both sides, our goal is to get all of the variables on one side and all of the constants or numbers without variables on the other side. When you do this, you kind of have a choice. So we're going to do this part a couple more times after we finish this problem. But which of these terms do we want to move? 6x, 4, 28, or 4x? Pick any of those four. Which one? The 4? Okay. So if we're moving this 4, when we move things, we are adding or subtracting it to the other side. So we're going to subtract this to the other side since it's already a positive. Since we moved 4 to the right, we now have to move our variables to the left. So whatever you choose here, you're always going to do the opposite in this step. So I'm going to move my 4x over by subtracting, because it's positive. And then now I have all my variables on one side, all of my constants on the other, so I can solve this like a normal problem and divide both sides by 2. You can just kind of do it how I did that. So x equals 12. We're going to do this problem 3 more times, just to show you that if you had picked a different thing to start moving, you would have gotten the same answer. So somewhere in your blank space, we're going to rewrite this step. The 6x plus 4 equals 28 plus 4x. Rewrite that somewhere on your paper. So we're still at the move step before we move 4, so let's pick a different term. 6x, okay. So if we move 6x, we now have to subtract because this is positive. So subtract 6x to the other side. We end up with 4 equals 28 plus 2x. We moved all our variables to the right, so now we have to move our constants to the left.
Minus 2x?
Yes, it is. Thank you. So now we have to move 28 to the other side by subtracting. Of course, my brain is not working just then. And then still divide both sides, but this time it's by a negative 2. So in this case, even though we picked something different to start solving this, we still got the same answer. Let's do it again. Somewhere in your blank space, rewrite this one more time. We're actually going to do it 2 more times, but just once for now. So we've moved 4 and 6x to start. We have 4x and 28 left. Which of those do we want to move? So 4x. So if we're moving 4x, we need to move it to the other side by subtracting. We moved our x's to the left, so now we have to move our constants to the right. So we have to get rid of this 4 by subtracting. You could continue to solve that, but we know it's going to equal 12 again. And then rewrite this one last time. And now we're going to move 28. So if we move 28, we need to subtract it. We're going to subtract it to the left. So we have 6x minus 24 equals 4x. We now have to get our variables to the right. So we have to subtract that 6x. And we end up at that same step where we had to divide by negative 2. So we end up getting the same thing. Now, when you solve these, you will not need to do these 4 different times. I was just showing you that each way works. So I may do this differently than you may do it differently than the person sitting next to you and across from you, and that's okay. Because there are 4 different ways to do this. As long as you are solving it correctly, we should all get the same answer. Anyone have any questions on that process? So on the next page, this is very similar to the last set of notes we were doing when it solved it for us and we had to determine what they did in each step. The only difference now is they have variables on both sides. So let's do a couple of these examples together and then I'll let you guys practice a couple. So starting with number 1, remember that first one is given as the original equation. What did they do from step 1 to step 2? Subtracted 2k on both sides. So that would be your subtraction property of equality. And then from step 2 to step 3, they subtracted what? I'm sorry, what number did they subtract?
Oh, sorry. 4. I'm sorry, they would add 4.
They would add 4. There you go. So that would be your addition property of equality. And then from step 3 to step 4, division. They divided both sides by 8. Questions on number 4? We're going to skip down and go to number 7. So the first one is given. What did they do from step 1 to step 2?
Distributed.
There was parentheses, now they're gone. They used that distributive property. From step 2 to step 3, what did they do there? To both sides?
I'm sorry, add 5.
Did they do that to both sides? Belinda? Yeah. So they combined that 5 and that negative 3 to get 2. And that 14
I'm looking at the wrong one. I'm sorry.
And that 14 and that negative 16 to get negative 2.
Sorry, I'm looking at the wrong one.
You're good. So for that one, that would just be combined like terms. And then from step 3 to step 4. What did they do there?
Add 2 this side.
Add this 2 to this side.
Next step 3 to 4.
I missed the last part. Keep thinking about that, Rabina. So they subtracted 2. They move this 2 to the other, I'm sorry, move this 2 to the other side. So these canceled, and this became -4. That's okay. So subtraction, property of equality. From step 4 to step 5. Now you have to. Yeah. And step 5 to step 6. Yeah. Divide both sides by -1. So it may help if you kind of break it down, look at each step, look at what they're doing, seeing what's changing. So I'm going to give you the next 5 minutes. It may not take you that long to do 5 and 6. Do those, compare your answers to the people around you, ask any questions you have, and then we'll come back and we'll check on that. So for number 5, from step 1 to step 2, they subtracted. And then divided. And that last one was supposed to be symmetric property. They just took n equals -6 and they switched the position of it to show you that it doesn't matter which way you write it. They're both the same thing. Do we have any questions on number 5? And then for number 6, they distributed. So distributed property. From there, they added 5w to both sides. And then they added 8 to both sides. So you had addition property of equality twice. And then they divided. The distributive, add, divide. Questions on number 6? Alright. On the next page, we're going to actually get through some examples, do some examples. And I'm not going to do all of these because I want you guys to try some, but we'll go through some. Let's start with number 2, and then we'll go on to 4 and do a couple others. So for number 2, I need to get all the variables to the same side. So I would start that off by moving my 3w so it's over here. And then dividing. So for your final answer, you can leave it as a fraction or a decimal unless it says specifically leave as a fraction. For questions like number 4, anytime you have a fraction that equals another fraction, think about these as proportions or ratios. And anytime we have a fraction that equals another fraction, what we're going to do is take this denominator, multiply it to this numerator, and this denominator, and multiply it to this numerator. So we're going to cross multiply. So those two words need to stay in your brain. Anytime we have a fraction that equals another fraction, we're going to cross multiply. So when we cross multiply, we can rewrite it. So I have 9 times 5x plus 5 equals 3 times 9x minus 3. It doesn't matter if I put this over here or vice versa, as long as you have them and they're set equal to one another. What I cannot do is put these together and these together, like 3 times 5x plus 5. I can't do that. They have to be across from each other, diagonally across. Once you have this rewritten, you can start solving it. So how would I start solving this one? So this would give me 45x plus 45 equals 27x minus 9. So we don't have like terms on the same side we can combine. So we're going to skip that step. Now we can move a variable or constant. What variable or constant do we want to move?
45x.
Okay. So if we move 45x, we are subtracting. What is that? Negative something. I think it is easy. Negative. And then because we subtracted 45 over here, we have to move 9 back over here by doing what? How are we going to move 9 back over here? We have 54 equals negative 18x. And then divide. I'm just rewriting it because I made a mistake. So anytime we have a fraction that equals another fraction, it doesn't matter if these fractions has only variables, only numbers, variables on one side, constants on the other, or some mixture of that. Anytime we have a fraction that equals another fraction, we're going to cross multiply. Multiply diagonally. Do we have any questions on number 4? We're going to do number 5, and then 6 or 7, and then 8 or 9. So for number 5, how would we start this? Distribute. So we have 30m minus 18. Remember, when we're distributing a fraction, think about that as 24 divided by 3 instead of 1/3 times 24. So 24 divided by 3 would give us 8. 12 divided by 3 would give us 4. And again, most of the time you multiply or distribute by a fraction, you're going to end up with whole numbers. Sometimes that's not the case, but most of the time it should be the case. And then we don't have like terms on the same side we can combine, so we need to move something. What do we want to move? Move the 30 by subtracting, yes. So this would be negative 22m plus 4. Since we moved our 30 to the right, we have to move our 4 to the left. And then divide both sides by negative 22.
What would the answer be?
Actually, I'm going to let you guys try it each hand out. Do we want to do 6 or 7 together?
7.
Both of these are solved the exact same way. We have a fraction equals another fraction, so we're going to do what to this? Cross multiply. Same thing for this one. We have a fraction equals another fraction, so still cross multiply. So we're multiplying 3 to everything here and 8 to everything here. Again, you can switch the sides. You can have this entire thing on this side and vice versa. That part does not matter. From there, the process is the same. Distribute. We don't have like terms on the same side we can combine, so we need to move a term. Which of these terms do we want to move? Go ahead. 3b. Okay. But Eric, if you want to move 9, that's fine too. So this would give me 5b minus 32. Then we would add 32 to the other side. You're going to get 23. So this is going to be a weird one where we end up with a fraction or decimal as the answer, and that's fine. Can I simplify 23 over 5? Sorry. So we can leave that as a fraction, or you can write the decimal. I don't know what that is as a decimal, but one of you can calculate that.
4.7. Certainty. 4.7. Pretty sure.
So either or, it's fine. The only time I would not suggest putting the decimal is if it's a repeating decimal or if you have a bunch of different decimals. Then I would leave it as a fraction. Yes, Avina.
So you can divide the fraction 1 into 1 side.
If we can't divide it, I didn't hear the last part.
If you can't divide that part, when we do the division on one side,
You're still dividing, but here I'm like dividing, but only this cancels. I'm still technically dividing here, I just actually didn't find the decimal. If that makes sense. I'm not simplifying it further. Right. Any other questions on this one? So left on this page are examples 1, 3, 6, 8, and 9. You have 5 problems to do. I'm going to give you about 10 minutes to do them. I'll check in at 10, see where we are. And then if everyone's finished around then, we'll go over them. If not, I'll give you a couple more minutes and then go over them. But you have this time to work. Here are the answers to those 5. The different colors are me doing it different ways, so you can look and see what way you did it to find that, but really just see is your answer the same. So for number 1, you should have got -4. Make sure you're writing k equals -4, not just -4. Number 3 was -1.4. Or C equals -1.4. -5, 6 was n equals 6. Eight was a equals -5. And 9, disregard this part. Y equals 4. These are both 9. I don't know why it says 9 and 10, but these are both 9. Yes. Yeah, this is between number 9, but this is number 8. 8 equals -5. What do you say? So this part in blue is wrong. 10 is 9. It's written, I don't know why I put 10. But y equals 4 was your correct answer. Oh, I see. Did this have an 8 in front of it? Yeah, yes, yeah. That's why this is wrong. This is the same one. Okay. Other questions on those? On the next page, you have more problems that are similar, but they're also a little different. So we're going to do 1 and 2, and then I'll let you try the other 4. So for number 1, we're going to solve this just like we would any other problem. Go ahead and distribute and bring down everything else. On this right side, we have like terms we can combine, so I'm going to go ahead and combine those two. Before we keep solving this, I want you to look at this look at both sides. What's the same and what's different about both sides?
The same is the variable and the different is the constant.
So these both have the same variable term, coefficient and variable, and these have different constants. That'll be important when we get to the answer. We'll come back to that. So now to solve this, what do we want to move? Sorry, which one? I was going to say which one? Okay. So if we subtract 5x over here, we also have to do that here. Either or. But when we do this, these cancel, nothing's left, except for 5. 5 minus 5x also cancels, nothing's left, except for negative 12. So when you get to this part, you have two constants. Does 5 equal negative 12?
No.
No. So because these two numbers are not the same, this is not a solution. This doesn't have any solutions. There's a blocked out part. You don't have to write this, but if it will help you remember it, you can definitely do that. So when we get a no solution for questions that have variables on both sides, we cannot put in any number ever back in for x. No number will ever work, no matter how many numbers you try. So this one will never have a solution. So if you get a question that looks like this, where you have the same coefficient, but different constants, light bulb should go off, bells should go off, that this is going to be a no solution. So if you can see that from this step, you don't have to keep solving it, but you do have to be able to explain that these have the same coefficient, they have different constants, it's going to be no solution. Do you have any questions on that one? Let's do number 2. Same thing, solve this like a normal problem. Start by distributing. We will in a moment. First, I'm going to combine these like terms. This negative 3 and this minus 7. And then we will subtract the 16 here in a second. But first, look at this equation. What do we notice about it?
Are equal.
They are equal. They're exactly the same on both sides. So kind of like this one, when you see something like that, light bulb should go off, bell should go off, that this is going to be a special case solution. So if we keep solving this and we subtract 6b from both sides, these cancel, we're left with negative 10 equals negative 10. Does negative 10 equal negative 10? Yes. So when you get this, and you have variables on both sides, this is going to be infinitely many solutions. Or IMS. So if you see, as you're solving it, that I have the same constant and the same coefficient on both sides, this is going to be infinitely many solutions every single time. So no solution, same coefficient, different constants, infinitely many is the exact same on both sides. The other thing is one solution, which is basically what we've been doing all this time, finding one solution. You know it's one solution if your coefficients are different. And then this little blurb down here. So for infinitely many solutions, every number possible would work. I could put in 1, it'll work. I can put in 10, it'll work. 5, 100, negative, 1,000,000. All of those numbers would all work for this. All the decimals, all the fractions, all your negatives, 0, all of them. Do we have any questions on this one? So you can get one of 3 answers for these questions. One solution where you have like x equals a number. No solution where you end up with this, or look at this step. Or infinitely many where you get this, or look at this step. Now for these questions on this page, you're just going to get infinitely many or no solution. Not one on this page. I want you to go through and I want you to do these last 4 on this page. I'll give you 8 to 10 minutes to do that. Then we'll come back and check those. And start on the very last page. If you finish these, you can move on to that very last page. I'm going to give you a hint to one of the word problems. We're going to do one, and then I'll explain what you're doing for kind of the remainder of class. Whoa. There's a lot going on in these problems, so I'm kind of going to walk through it. But these are 2 different ways that you, some of them have 2 different ways. So for this first one, if you distributed and then saw that these were the same, you could have stopped there and said that this was infinitely many solutions. You could have also kept going, and you would have got 12 equals 12 to signify that that's infinitely many solutions. For number 4, you needed to combine these like terms. I'm sorry. This first, this way I'm doing it gets rid of the fractions. I don't know if I have the other way. If you combine your like terms here and then got rid of it, either way you did that, you would have saw that this was no solution. It's very close, but not quite. 5 was no solution. You ended up with 3x minus 13, 3x plus 42, or negative 13 equals 42. And then for number 6, you should have saw that these were the same, 3x plus 6 and 6 plus 3x. Even though they were switched, they still have the same constant, same coefficient. Or if you solved it, you would have got 6 equals 6. So 6 IMS, 5 no solution, 4 no solution, 3 IMS. Do you have questions on either of or any of those? So let's jump to that last page. So for number 1, I'm going to give you a hint, a couple hints actually. This is talking about area. To find area of a rectangle, it's your length times your width. So if it gives you your length and your width for each rectangle, that's how you will find your area. Your second hint for that is if they have the same area, that means they should be set equal to each other. So those are your hints for number 1. We're going to walk through and do number 2. So circle, highlight, underline, anything that's important. For number 2, Chris has saved twice the number of quarters that Nora saved plus 6. The number of quarters Chris saved is also 5 times the difference of the number of quarters Nora saved and 3. Write and solve an equation to find the number of quarters they each saved. So, for this, what's important here?
Twice.
Eric and then Saeed. Twice.
Yeah.
Twice what?
The number of quarters.
Okay. Saeed.
Plus 6.
Uh-huh. And then, what else is important?
Save and 3.
What are they talking about here? Yes. Keep reading that sentence. Something about Nora saved. What are they doing with that and 3? So the difference of M3 and then 5 times. And we have to find the number they each saved. So for our variable, I'm just going to use x for the number of quarters Nora saved. For this, because both of these equations are for Chris, we'll come back to that part about a variable. So x is going to be the number of quarters Nora saved. We know that Chris has twice the number of quarters saved plus 6. How would we write that part?
2x plus 6.
Yeah. Then it says is also,
5 times.
so it's going to be equals, and then 5 times the difference of the number of quarters saved and 3. How would you write that part?
2x.
At 5, and then parentheses.
And my 3.
Sure. I use x, but sure. Oh, yeah. So this is Chris's equation. This is also Chris's equation. So both of these are for Chris, but the x is Nora. So we can solve this, figure out what x is, and then go back and find Chris's. So after we distribute, we have different things we can move. What do we want to move?
2x.
Okay. So subtract 2x to the other side. If that's not what you chose, that's fine. And then because we moved 2x over here, we have to add 15 back. And then divide.
Then you get 7.
So 7 is for Nora. So I would say 7 quarters to put my units. Or the number of quarters Nora saved. Now to find the number of quarters Chris saved, I'm going to put 7 either into this part or into this part. Not into both. Just because they would equal the same thing, that'd be extra work. So you can put it in here, or you can put it in here. Either way, they should equal the same thing though. How many quarters does Chris have?
20.
20. You guys don't have a whole lot of time left in class, but if you wanted to get this done, you do have two Khan Academies. You may have tried them already. It probably makes a little bit more sense now that we've gone over these notes. Both of those Khan Academies, the equations, solving equations and inequalities quiz, and the number of solutions to an equation are both based on these notes. The Delta Math, the solving multi-step equations with variables on both sides, is based on these notes. So the Khan Academies are due Friday. Delta Math is due Thursday. If you don't get those done in class, work on them afterwards. If you see any that you get stuck on, have questions on, and you don't get to it in class, make sure you come before or after school. Ask me about those. We can work through those together. I would say either try these two examples or try one of the Khan Academy or Delta Math for like the next 5 minutes, and then I'll let you grab your phones. So don't grab your phones just yet.